Hey everybody, welcome to Geometry 2, Section 11.5, Volume of Pyramids and Cones. By the end of this lesson, you should be able to find the volume of a pyramid, use Pythagorean theorem to find missing lengths, and find the volume of right and oblique cones. So let's talk about the volume of a pyramid. So we've talked about the area of a triangle before, and of course we know that the formula for that is 1/2 base times height. Okay, and so this is a two-dimensional figure, but when we talk about a pyramid, okay, this is no longer a two-dimensional figure, it's a three-dimensional figure. So a good way to remember the formula is instead of, base times height, it's going to be area of the base times height, but because it's a three-dimensional figure, it's going to be 1/3, not 1/2. Okay, so any pyramid or cone is going to have 1/3 in it because it's a three-dimensional figure. So let's use that formula. Volume equals 1/3 area of the base times height. Again, when it's a capital B, that means the area of the base, as opposed to lowercase b, which meant just the length of the base in a two-dimensional figure. So if my base is 4 centimeters by 4 centimeters, that makes the area of the base 16. And then the height is going to be 9 centimeters. So I plug that in, calculate it, and I get 48 cubic centimeters. Let's try that again. This time we have a triangular pyramid. So when we do the area of the base is that right triangle down there. So let's get a better look at that. So it's okay to take a shape and kind of draw it off to the side. So the base and the height are 6 and 8. So plug that in, and 1/2 6 times 8, that gives us 24 square feet as the base. So let's plug that in, and then our height, which is going to be perpendicular to that base, so we can see that this 12 is perpendicular to that base. So we plug that in, calculate it, and we get 96 cubic feet. Let's do one more. So we use 1/3 area of the base times the height. So area of the base looks like I'm going to do 14 times 14, which if they only give you one side of the base, assume that it's a regular shape. So whether it's a regular pentagon, a regular hexagon, or in this case, a square, assume that. Otherwise, you'd have a bunch of problems where like, I don't have enough information. Next, not enough information. Next, not enough information. I'm killing it. So for area of the base, we do 14 times 14, and we get 196. The height looks to be 25, except at 25 is the slant height. When we talk about the height for volume, we want the actual height, the thing that goes from the apex clear down to the center of that base. Okay, we don't want the slant height. So let's back that up a little bit. We don't want the 25 to go there. Instead, we need to use some Pythagorean theorem to figure out what that height is. So I kind of drew this little triangle where one side is the height, the other one's the slant height. To figure out the bottom of that triangle, well, if the length of the base is 14, then the other part of that triangle is going to be 7, just half of 14. Do a little Pythagorean theorem, 7 squared plus h squared equals 25 squared. Work that on out. And h ends up being 24. So we got a nice whole number on that one, so that's kind of cool. So now that I know that the actual height is 24, let's go ahead and plug that into the formula. So 1/3 times 196 times 24, that's going to be 1,568. So let's apply what we just learned to the volume of a cone. So we know that the volume is 1/3 area of the base times the height. And again, the area of the base of a circle is going to be pi r squared. So you plug that in, and it's 1/3 pi r squared h. So if you didn't notice, in our previous lesson, we talked about prisms and cylinders. So the volume for a cylinder was just pi rh squared. So cone is going to be 1/3 pi rh squared. Volume of a prism was just area of the base times the height. Area of a pyramid is 1/3 area of the base times the height. So they're the exact same formula. except when it's a pyramid or a cone, you just slap the 1/3 in there. So hopefully that helps you remember all these different formulas. Also, you're allowed your reference sheet, so there's that. So let's use this formula. Volume equals 1/3 pi r squared h. And again, I like cylinders and cones because all you got to do is just plug it in. So my radius is 2, my height is 8, and then you work that on out. And so I get 4 times 8, which is 32. And then I can't really take 1/3 of 32. So my exact answer on this is just going to be 32 pi over 3. And if MathXL wants an exact answer, that's what they're going to want to see. So be aware of that. If it doesn't come out to be a whole number, just leave it as a fraction. If pi is involved, leave pi in the numerator. Now, if they wanted a rounded answer, we can definitely plug that into our calculator, and that would give us 33.51 cubic inches. Let's do the same thing for this cone. Let's see, our radius is 7, so I can plug that in. The height, okay, don't fall for the trap. That 18, that's the slant height, okay? So in order to find the actual height, we got to do a little Pythagorean theorem. So let's set that up. So h squared plus 7 squared equals 18 squared. Hopefully you can see pretty clearly the right triangle right there. So I didn't draw another little diagram. If you wanted to, that'd be fine. We'll work that on out. And the square root of 275 is 5 square root of 11. Or you might get a decimal on that one. So this does not turn out to be a whole number. So, you know, however you want to do it. If you want to leave it in simplified radical form or as a decimal, that'd be fine. Either way, you take that height and you plug it in. And then you keep going with your calculator. And that would be the exact answer. But let's see, we've got a pi and a square root in there. Man, let's just convert it all to a decimal. Or not. If you wanted to put it into a decimal, you could. But yeah, that would be the exact answer right there. Okay? So now let's talk about the volume of an oblique cone. So an oblique cone is basically a cone that's not perfectly with the apex centered over that circle. So if you take that apex and you kind of shift it over a little bit, that's what makes it oblique. All right. So here we have an oblique cone with the radius being 9 and the height being 6. Okay, and again, that height is always going to be perpendicular to the base. So they made a point to show that this 16 is perpendicular. Even though it touches outside the circle, it's still perpendicular to that plane. But for an oblique, the formula doesn't change. It's still 1/3 pi r squared h. So you plug in the 9 for the radius, the 16 for the height. You get 1/3, 1296, which just turns into 432 pi. So whether it's oblique or whether it's right, meaning the apex is directly above the center of the circle, it doesn't matter. You still use the same formula. So hopefully you guys found this lesson just as easy. It's very much just here's the formula, plug it in. You might have to do some Pythagorean theorem here or there, but other than that, it's pretty straightforward. So if you guys have any questions, please feel free to let me know either via email or in class. I'd love to help you in any way that I can. But I will see you guys real soon. Have a good one.